Have you ever seen the arc move erratically from side to side while welding? This is called arc blow. Arc blow prevents the weld bead from being smooth and significantly reduces the weld quality. In this video, I'll explain step by step in a clear and simple way why arc blow occurs and how you can eliminate this problem. While welding, electric current forms a closed circuit between the electrode, arc, workpiece, and ground cable. A magnetic field is created in the area where this current passes. If this magnetic field isn't distributed evenly in the weld zone, the arc deflects to the left, right, or backward instead of heading straight into the weld pool. So how do we prevent arc blow by correcting this magnetic field imbalance? The first thing to pay attention to is the position of the ground clamp. The ground cable should not be left coiled, it must be fully unrolled for use. The ground clamp should be connected as close as possible to the welding area and positioned behind the electrode. Because if the ground clamp is too far away, the welding current follows a longer and more unstable path across the part. This can cause the magnetic field to form unevenly in the weld zone. Also, if multiple welders are working on the same part, the ground clamps should not be connected close to each other. The second thing to consider is the amperage setting. If the amperage is excessively high, the welding current also increases. As the welding current increases, the magnetic field generated in the weld zone gets stronger. This can increase the arc's deflection to the left, right, or backward. Therefore, the amperage should be adjusted according to the electrode diameter and material thickness used. You can find the correct amperage settings for the 3 most commonly used electrodes on my YouTube channel, Emin Academy. The third thing to watch out for is the arc length and the holding angle. If the arc length is too long or the electrode is held at too low an angle, the arc becomes more unstable. In this case, the arc can deflect more easily to the left, right, or backward due to the magnetic field. Therefore, for electrodes with a 0 or 1 as the last digit, the arc length should be equal to the electrode diameter and it should be held at a 15 to 30 degree angle from the vertical. For electrodes with a 2, 3, or 4 as the last digit, the arc length should be half the electrode diameter and it should be held at a 15 to 30 degree angle from the vertical. For electrodes with a 5, 6, or 8 as the last digit, the arc length should be as short as possible and it should be held at a 5 to 10 degree angle from the vertical. Arc blow can become more pronounced, especially when approaching the end of the weld. So when approaching the end of the weld, the arc length should be kept short and the electrode angle should be adjusted more carefully. This way, the arc can be prevented from moving away from the weld pool. Also, if the coating of the electrode used is off-center, it can lead to arc blow. If arc blow continues despite all these adjustments, the workpiece may be magnetized. Magnetization is when the metal part behaves like a magnet. This usually happens if the part was moved with a magnetic lifter, exposed to strong magnets, or welded with direct current for a long time. In such a case, alternating current can be used if possible to reduce arc blow. In alternating current, the current direction changes 50 to 60 times per second. Since the current direction changes constantly, the magnetic field doesn't stay fixed in one direction. This makes it harder for the arc to constantly deviate in the same direction, reducing arc blow. In this video, we've explained step by step clearly and simply why arc blow occurs and how to eliminate this problem. If you found this video helpful, don't forget to like it and subscribe to the channel for more stick welding tutorials. See you in the next video.